So density altitude is the altitude in the standard atmosphere where a particular air density can be found, and it accounts for non-standard pressures like pressure altitude, but it also accounts for non-standard temperatures, which pressure altitude does not account for, because air density is affected both by pressure and by temperature. So under higher air pressures, the air molecules are packed more closely together, and under lower pressures, they are not packed so closely together. So this is more dense, this is less dense. With temperature, at higher temperatures, the air molecules are moving around faster and they spread out more, so the air is less dense. And at lower temperatures, they're moving a lot less and they can get packed closer together and they are more dense. Density altitude is used in performance calculations because air density affects the way the airplane performs, both because it affects the amount of air molecules flowing over the wing or over the propeller blades, which affects the amount of lift or thrust that can be produced, and it also affects how much oxygen is available to be taken into the engine for combustion, which affects thrust. So where pressure altitude was the altitude in the standard atmosphere where a certain pressure level could be found, density altitude is the altitude in the standard atmosphere where a certain air density can be found. So higher than normal temperatures or lower than normal pressures are both going to result in a higher density altitude. And pressure altitude adjusted for non-standard temperature will give you density altitude. So how can we actually compute it? One way is to use an E6b. You can enter the pressure altitude in thousands of feet in this window here. And on this scale up here, we've got air temperature in degrees Celsius. So if you know your pressure altitude and your air temperature, you can line them up here and then read the density altitude in this window up here. Another way would be to use a density altitude chart like this. We've got air temperature on the bottom here. So you would start at the air temperature, and these lines here are pressure altitude, and you would go straight up until you reach the pressure altitude. Say it was, 16 Celsius and 3,000 feet pressure altitude. And then you would move over and find the density altitude on the side here, about 3,500 for that example.